Okay, let's dive right into this. I want you to imagine for just a second that you are walking onto the trading floor of a major international stock exchange. The clocks on the wall are ticking down relentlessly. The screens are flashing with endless streams of data, and split-second decisions literally mean the difference between a massive, life-changing win and a devastating total loss. That high-stakes pressure cooker environment, that adrenaline spike, that is exactly what it feels like when you walk into the exam hall for your Cambridge computer science papers, whether you are sitting the 0478, the 2210, the 0417, or the 9618 syllabus. You have an incredibly limited amount of time on that clock, and you absolutely need to invest your minutes exactly where the mark scheme pays out the highest. You simply cannot afford to waste time on low-yield waffling. Today, we are focusing our entirely revamped exam strategy on a topic that catches thousands of well-prepared students completely off guard every single year: hexadecimal representation. We are going to completely transform how you approach this topic. We are not just going to talk about basic base 16 math. Anyone can do that. Instead, we are going to look at the exact split-second decisions you need to make the moment your eyes scan a question. We'll show you how to guarantee you extract every single mark available from the examiner. We are building your ultimate computer science success blueprint right here, right now. So grab your notebooks, get focused, and let's start maximizing your grade potential.
Here is our agenda for today's explainer session. First, we'll tackle the definition trap. Second, we'll build up the 3 layers of understanding. Third, we'll decode the difference between description and explanation. Fourth, we'll unlock the power of context. And finally, we will lock it all in with the 4-question anchor.
Let's move straight into Section 1, which we call the definition trap. We're going to look closely at why going beyond mere vocabulary is absolutely crucial for your success, and why so many students lose easy marks by treating computer science like a simple dictionary test.
Now, what is really interesting about this actual past paper exam-style question are the specific command words used: state and explain. To perfectly illustrate the trap students fall into, I want to introduce you to 2 archetypal test takers we see in our grading piles every single year. Let's call them Alex and Sam. Now, Alex is incredibly hardworking. Alex stays up late, highlights everything, and memorizes the textbook literally cover to cover. When this question pops up on the paper, Alex overloads the answer with raw facts, but provides absolutely zero analysis. Alex writes, hexadecimal is base 16 and uses A to F to represent 10 to 15. It is used in MAC addresses. Now let's look at Sam. Sam is smart but always rushing, always watching the clock, and completely misses the command word requirements. Sam just wants to get to the next page. Sam writes, hex is shorter than binary, so it's better. So what happens when the examiner takes out the red pen? Neither of them gets full marks. It's a tragedy. Alex gets 1 single mark for stating a fact, but completely and utterly fails the explain portion of the command word. There is no deeper analysis, no evidence, no logical progression. Sam, on the other hand, gets maybe half a pity mark for the vague idea of it being shorter, but fails to use any accurate Cambridge terminology. Both Alex and Sam are treating a complex digital problem as if it's an isolated vocabulary test. That is exactly what Cambridge examiners do not want to see. They want to see how you analyze the problem, not just how well you can regurgitate a definition.
A top-tier grade 9 equivalent answer must begin by identifying exactly what digital problem hexadecimal solves before jumping into basic terminology. Why on earth did computer scientists invent this representation method in the first place? Computers only understand binary, ones and zeros. We all know that. Hexadecimal is not for the computer at all. It is entirely for the human beings interacting with the computer. Imagine a network engineer trying to type in a 48-bit MAC address in pure binary. It would be a relentless, endless string of ones and zeros. The probability of human error, of a misdiagnosis, or a transcription mistake is massive. Hexadecimal solves the fundamental problem of human readability. It compresses long binary strings into manageable chunks. 1 hexadecimal digit perfectly represents 4 binary bits, which we call a nipple. When you deeply understand that the core problem being solved is human error in data entry and the absolute need for easier system diagnostics, your exam answers instantly elevate from rote memorization to high-level system analysis. To structure this analysis perfectly, top students use the PEAL framework: point, evidence, explanation, and link. We'll be applying this framework to decode these command words today. But hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It's the only way to ensure you don't miss these crucial grade-saving strategies.
Moving right along to Section 2, The 3 layers of understanding. This pedagogical framework is the absolute core of structuring high-scoring answers. If you can master these layers, you will never stare blankly at a blank exam page again.
To truly master these layers and secure those top marks, we need to apply that Peel framework we just mentioned. Examiners are actively, aggressively scanning your paragraphs for these 4 elements: point, evidence, explanation, and link. If they aren't there, the marks aren't there. Step 1 is everyday language. This is where you explain the concept simply in your own head to make sure you get it. Hexadecimal is just a shorter way for humans to read long computer codes. Step 2 is technical vocabulary, upgrading that simple language to Cambridge standards. Hexadecimal is a base 16 number system used to represent binary data in a more compact format. But step 3, the exam explanation, is where you deploy Peel and the red pen marks literally transform into green check marks. Let's watch Alex rewrite that flawed answer from earlier live right now. Applying the framework, Alex now writes, hexadecimal is used to represent MAC addresses. Boom, that's the point. For example, a 48-bit binary address is converted into 12 hexadecimal digits, perfectly stated evidence. This grouping of 4 bits into 1 hex character makes it significantly easier for technicians to read and identify hardware components. That is a stellar explanation, thereby reducing the risk of data entry errors when configuring a local area network, and there is the link back to the real world. Bam! Full marks. It is flawless. That is the computer science success blueprint in action. That is the power of moving systematically through the 3 layers rather than just vomiting facts onto the page.
Look at this quote on the screen. Students often think they know a topic until they try to express it in that 3rd layer. I want you to really absorb that. You sit in class, you see a familiar keyword like hexadecimal, and you feel a massive rush of confidence. You think, oh, I've got this. But that surface feature is a total distraction. You think you know it because the everyday language layer feels so comfortable, but when the clock is ticking and your pen actually hits the paper, you freeze. You start confusing memory with storage or data with information, your sentences run on, and the logic falls apart. This is exactly why practicing past papers isn't just about reading the mark scheme, it's about forcing your brain to physically write out that 3rd layer under pressure. You must recognize that knowing the name of a device is completely fundamentally different from explaining its function to an examiner. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back to the strategy.
Welcome to Section 3, Description versus Explanation. This is where we kick off our interactive workshop phase. You absolutely must separate these 2 concepts in your mind to capture full marks.
The exact boundary you need to firmly cross in your mind is the distinct difference between what, how, and why. A description simply tells the examiner what the device, process, or method is. An explanation, however, tells the examiner how it works and why it matters in the real world. Cambridge examiners find purely descriptive answers to be safe, sure, but incredibly shallow. They will cap your marks. Let's do a quick mental challenge right now. I'm putting 60 seconds on the mental clock. Imagine a massive, complex data source, like a raw memory dump from a crashed server system, and it is displayed entirely in hexadecimal. If the exam question asks you to explain why the memory dump is displayed this way, and you write, the memory dump uses base 16 letters and numbers, well, you have only described it. You've stated a fact. You've earned maybe 1 mark. To get the rest of the marks, you must pivot to how and why. You need to write, the memory dump is displayed in hexadecimal because it allows system developers to trace errors much more efficiently. Since 2 hex characters perfectly represent 1 entire byte of binary data, developers can quickly identify specific memory addresses and debug catastrophic system crashes without sifting through millions of unreadable error-prone binary digits. That, my friends, is a true explanation. You extracted the core trend and explained the why.
To ensure you always hit that deep explanation without panicking, you need to use a time management matrix. Here is the chronological, minute-by-minute sequence of an ideal exam answer for a standard 4-mark question. At 0 minutes, your eyes hit the paper. You immediately identify the demand. Is the command word state, describe, explain, or evaluate? At 1 minute, you classify the concept. Are we talking about HTML color codes, MAC addresses, or IPv6 routing? At 2 minutes, you explain the mechanism. This is the absolutely crucial pivot point. You explain how it works first. And finally, at 3 minutes, you state the consequence. Why does it matter to the end user? Explaining the mechanism first and the consequence second drastically improves your logical flow. Now let's play Find the Flaw. Listen closely to this sample paragraph and try to identify the sentence that is losing marks. Hexadecimal makes websites look better. HTML uses it for colors. It uses a hash symbol followed by 6 characters. Time's up. Did you spot the flaw? The flaw is the very first sentence. Makes websites look better.
is a consequence stated without any mechanism. It's totally vague. An examiner will give that 0 marks. A top student uses the timeline matrix instead. HTML uses hex codes. It pairs red, green, and blue values into 3 distinct bytes, allowing web designers to accurately specify over 16 million colors without using complex, easily mistyped binary strings. See the difference? Mechanism, then consequence.
Let's transition into Section 4, the power of context. This is where we discuss real-world transfer and why generic answers are destroying your grade potential.
So, the crucial, unavoidable point is this. Generic floating responses rarely, if ever, gain full marks in a Cambridge computer science paper. Your answer must stay strictly and relentlessly inside the specific scenario given in the prompt to prove you understand how technology interacts with actual human environments. If an exam question asks why hexadecimal is used in a school management tools network, you must specifically talk about the school's IT technician managing the MAC addresses of the students' tablets. If the scenario is about industrial automated systems or robotics, you must discuss memory dumps and error codes being flashed on an LED screen for engineers out on the noisy factory floor. Do not, under any circumstances, memorize a generic textbook answer about it just being easier for humans to read and paste that into every question. It won't work. Name the person, name the environment, and link the technology directly to their specific daily digital problem.
Let's move to our third challenge, speed writing. But first, look at these common mistakes. Being error-aware in your preparation is incredibly useful. Look at this list. Vague wording, like "it's faster," without explaining why it's faster. Confusion between similar terms, like mixing up hardware MAC addresses with logical IPv4 addresses. Missing vital steps in a process, like jumping straight to human readability without ever mentioning the 4-bit nibble grouping mechanism. Ignoring the given context entirely. And finally, stating an advantage without giving a valid reason. The direct, 100% effective antidote to all of these errors is writing a perfect PO paragraph. Let's do a 30-second speed writing drill in our heads right now to lock one in for an advantage of hexadecimal. Point: hex is highly compact. Evidence: it condenses 8 bits of binary into just 2 characters. Explanation: this means system error logs take up significantly less display space on a tiny diagnostic screen. Link: therefore, the technician can view entire memory dumps at a single glance without scrolling endlessly and missing a critical fault. That is exactly how you avoid these traps and dominate the mark scheme.
We have reached Section 5, the 4-question anchor. This is your ultimate self-check tool for checking and refining your knowledge before you ever step foot in the exam hall. Let's pull everything together and present the complete computer science answering system. This 2x2 matrix builds your final defensive line. There are 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, PO framework application. Rule 3, the time management matrix. You apply those rules using this table. If you can answer these 4 questions aloud without looking at your notes, the topic is truly ready. Top left, what is it? It's a base 16 number system used to represent binary. Top right, how does it work? It groups binary into 4-bit nibbles, assigning numbers 0 to 9 and letters A to F. Bottom left, where is it used? It's used in MAC addresses, HTML color codes, memory dumps, and IPv6 routing. Bottom right, why is it better or worse than an alternative? It is vastly better than binary because it reduces human transcription errors, but it is worse in the sense that it is not understood directly by the CPU, requiring an extra step of conversion. If you can rattle that off, you are golden. I want to end this explainer with one final, deeply provocative question for you to take into your next revision block. Can you explain the mechanism without relying on memorized wording? If I took away the words base 16, nibble, and MAC address, could you still explain the core concept of why we group data for human eyes? Paraphrasing accurately is the absolute true test of exam readiness. It proves you own the concept, rather than the concept owning you. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.